Section 8.1 is right triangle trig. So in this section, all of our triangles are going to be right triangles, which means one angle is going to be 90 degrees or a right angle, which we denote with this little square box here. Then our theta is going to be one of the non-right angles, so one of the other two angles. And then the way we label is the angle that is the side that is across from our angle theta is our opposite leg. The side that is attached to our angle, not the hypotenuse, is the adjacent leg, and then the hypotenuse is always directly across from the right angle. So now if we look at our trig ratios, we have our trig ratios that we talked about in chapter 5, and now we want to relate them to right triangles. So we have this right triangle here, where x is one side, y is another side, and r is the hypotenuse. If we call this angle here theta, then sine is y over r, which is equivalent to the opposite side over the hypotenuse. Cosine is x over r, which is equivalent to the adjacent side over the hypotenuse. And tangent is y over x, which is equivalent to the opposite side over the adjacent side. So to remember that, we have the phrase SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We don't really use the other three trig functions much in right triangle trig, but they're always just the reciprocal of the other ones. So when you see a question that says solve the triangle ABC, that means find all its missing angles and sides. So the way that we label a triangle, capital letters are angles. We'll also use alpha, beta, and gamma instead of capital A, capital B, and capital C. Lowercase letters are sides, and the side is always directly across from its corresponding angle. So if this is angle A, then this is side lowercase a. If this is angle B, directly across from it is lowercase b. If this is angle C, directly across from it is lowercase c. So if you see a problem that says lowercase c is equal to 5, that means the side C is equal to 5. Versus over here you have capital B is equal to 40 degrees. That means the angle B is equal to 40 degrees. So if we try example number 1 down here, they tell us that side C is equal to 5 and side A is equal to 2. We know that angle gamma, or angle C, is equal to 90 degrees because they tell us that that's the right angle. So I'm going to start with solving for angle A because I have its two corresponding sides. So I know that the sine of capital A, or alpha, is equal to opposite over hypotenuse. So that means it's equal to 2 over 5. So now I know that the sine of the angle is equal to 2 over 5. So if I want to figure out what the actual angle is, I use my inverse trig. So alpha has to be sine inverse of 2/5. Now that's not something on the unit circle, so now you're just going to use your calculator. Make sure your calculator is in degree mode before you plug it in. So if you plug in your calculator, you get that angle alpha, or angle A, is equal to 23.578 degrees. Remember, we always round to 3 decimal places. So now that we know alpha, we can use alpha to find side B. So we can use this angle and the hypotenuse to find the adjacent side. So what trig function would that be? So we want to use the cosine of alpha is going to equal side B over the hypotenuse. So plug in what you know. You know that alpha is 23.578 degrees, and we know that C is 5. So multiply both sides by 5, you get that side B is 5 cosine 23.578 degrees, and go ahead and plug that in your calculator. So once you plug that in your calculator, you find that side B is equal to 4.582. So now we have all the sides and angles except for angle B, or beta. So go ahead and pause the video and find angle B. So there's multiple ways you could have found angle B. You could have said that all 3 of the angles have to add up to 180 degrees. We know 2 of the angles, gamma and alpha, so 180 degrees minus that. You could have also said the cosine of beta is the adjacent side 2 over the hypotenuse 5, which is the way that I wrote it out here. Or you could have also said that the sine of beta is equal to opposite side b, which you just found, over hypotenuse side 5. Either way, or any of those ways, you should have gotten that beta was 66.421 degrees. So now go ahead and pause the video and try example number 2. Again, we also know that angle C is our right angle 90 degrees. So go ahead, draw out your triangle and use this information to find the 3 missing parts. So right off you can find angle alpha, or angle A. You know that angle B is 40 degrees and angle C is 90 degrees, so angle alpha, or A, has to be 50 degrees. So then I use that information. I use sine is opposite over hypotenuse, so you get sine of 50 degrees is equal to 6 over C, and use that to solve for C. And then I use that tangent is opposite over adjacent, so I did tangent of 40 degrees is B over 6, and use that to solve for B. Last couple notes. The first is angle of inclination. Angle of inclination is a term that you need to know for a lot of these word problems, and it's how much you look up. So if your eyes are level here and you have to look up to see the top of a mountain, that angle that you have to look up is your angle of inclination. Similarly, your angle of declination, or a lot of times you'll hear it called angle of depression, is how much you look down. So if this is your eye level and you have to look down to see the ground, that angle you have to look down is your angle of depression. The last thing is the complementary angle theorem, which says that cofunctions of complementary angles are equal. So what that means is if you have a right triangle and you have alpha, beta, ABC, then the sine of alpha is the opposite, which is A, over C. But that's also the same thing as the cosine of beta. Adjacent is A over hypotenuse is C. Similarly, if you have the cosine of alpha, that's adjacent, which is B, over hypotenuse, which is C, which is the same thing as the sine of beta. Opposite is B over hypotenuse is C. So what that means, alpha and beta you know are complementary angles because all 3 angles in a triangle have to add up to 180 degrees. One of them's already 90. So alpha plus beta has to equal 90 degrees. So that means that the sine of alpha is equal to its cofunction, cosine, of its complementary angle. So alpha and beta add up to 90 degrees, so they're complementary. Sine and cosine are cofunctions.